You are watching the Chemical Processing Fundamentals video series, Guide to Flow Meters. This video is brought to you by our sponsors, A.W. Lake and KROHNE. More information on our sponsors will be provided later on. You can also find company and product information provided in the information section below.
Maintaining proper process control and performance usually requires measurement of flow. No single type of flow meter suits all services. Choosing the most appropriate instrument for a given application involves weighing a variety of technical considerations, as well as, of course, cost. So here we'll touch upon various factors to keep in mind and also look at common flow measurement technologies. Key parameters to consider include the nature of the fluid, that is, whether it is a gas, liquid, or multiphase, and whether it may contain suspended solids or entrained air. Fluid characteristics such as temperature, pressure, density, viscosity, and so forth, as well as likely maximum and minimum flow rates during normal operations. Whether you need volumetric or mass flow measurements. The accuracy, repeatability, and response time desired. The device's location, for instance, whether it will be put in a hazardous environment requiring an instrument with certain approvals. Installation requirements, including whether placing an element in the fluid stream is acceptable or not because of pressure drop, safety, or other reasons. The amount of upstream and downstream straight pipe length available, and materials of construction needed. The maintenance necessary and your site's familiarity with doing such work. And total cost of ownership, not just initial purchase price. Now, let's look at 8 common types of flow meters. In a differential pressure meter, a restriction called a flow element placed within a pipe creates a pressure drop. The amount of the pressure drop relates to the volumetric flow. Sensors upstream and downstream of the element enable determining the differential pressure and hence the flow. The most common restriction is a precisely machined orifice plate installed concentric to the pipe diameter. Some applications are better handled, though, by using other flow elements such as venturis, nozzles, pitot tubes, and wedges. DP meters offer a number of advantages. For instance, they are well understood technology. They have no moving parts and are suitable for gases and liquids. Moreover, they can withstand severe process conditions. On the other hand, they provide limited turndown, are less accurate than other technologies, and their flow element can wear, which will decrease accuracy. In addition, they are affected by changes in density, pressure, and viscosity. Vortex flow meters rely on the so-called von Karman effect. That flow encountering an obstruction inside a pipe generates recurring vortices on either side of that obstruction, which is called a bluff body. The frequency of the oscillations between consecutive vortices, measured by a piezoelectric device, directly corresponds with flow velocity. Swirl meters use a different type of obstruction, one that creates a spiral flow of fluid. The speed of the swirl's rotation correlates with flow rate. On their plus side, these types of meters are suitable for liquids and gases and have no moving parts. They incur low pressure drop and provide good to excellent accuracy. And for the swirl design, they only require short inlet and outlet straight piping runs. Against that, though, they are not great for dirty or abrasive fluids and are not suitable for high viscosity fluids. And their accuracy suffers when subjected to pulsating flows. In addition, Vortex designs need long inlet and outlet straight piping runs. A turbine meter contains a multi-vane rotor that spins at a rate proportional to fluid velocity. A sensor detects the rotation rate of the rotor, which can turn in either direction. Its advantages include that it's well understood technology and that the device provides high accuracy and repeatability as well as broad turndown. On the negative side, it is only suitable for clean fluids and requires periodic recalibration and maintenance. A variable area meter, which often is called a rotometer, consists of a tapered vertical tube containing a float. The float's position in the tube reflects the balance between its weight and the upward flow, and is a linear function of flow rate. Using a transparent tube enables the taking of direct readings. The rotometer is simple and reliable as well as inexpensive. It can cover a wide range and causes little pressure drop. In addition, you can get a local reading without the need for any power. However, the device provides relatively low accuracy and is only good for the range specified. Also, accurate results require proper calibration for the particular fluid in the tube. A magmeter relies on Faraday's law of electromagnetic induction, that a conductor moving through a magnetic field induces a voltage. So the device only is suitable for conductive fluids such as water and aqueous solutions. Coils on the outside of the pipe generate the magnetic field, while a pair of electrodes measure the induced voltage, which is proportional to fluid velocity. The magmeter offers a number of advantages. It has no moving parts or obstruction in the flow path and causes no pressure loss. Temperature, pressure, and viscosity don't affect results. In addition, the device can cope with a high turn-down ratio, can handle conductive slurries, and can measure low conductivity levels. Plus, it doesn't require too much straight piping upstream and downstream. Its disadvantages include that it's only good for conductive fluids and can have problems getting good measurements for weakly conductive fluids. Moreover, units may be heavy and expensive. A thermal mass meter has a heated sensing element isolated from the fluid flow path. The fluid conducts heat away from the element at a rate directly proportional to the mass flow rate. The device has the pros of measuring mass flow rate and that it usually is relatively low cost. Cons include that it provides low to medium accuracy and generally is limited to clean gases of known heat capacity. Ultrasonic meters come in two varieties, transit time and Doppler. Both assess the impact that moving fluid has on the speed of sound to gauge flow rate. The former uses upstream and downstream transducers and measures the difference in transit time between the two ultrasonic signals. The latter relies on a single transceiver and measures the frequency shift of sound waves reflected from suspended particles or bubbles within the flowing stream. An ultrasonic meter offers a number of advantages, such as not having moving or wetted parts and not causing a pressure loss. Moreover, it can handle corrosive fluids and is insensitive to changes in temperature, pressure, density, or viscosity. It also offers large turndown. Clamp-on versions ease getting data on a temporary basis and for troubleshooting. Disadvantages include that it provides medium to low accuracy, flow profile affects results, and precision declines at low flow rates. A Coriolis meter takes advantage of the so-called Coriolis effect, that fluid passing through a vibrating tube will cause some twisting of the tube. Sensors measure the degree of twist, which directly relates to mass velocity. The Coriolis meter gives high accuracy measurements of mass flow rate while simultaneously being able to provide density measurements. It is suitable for liquids and gases and can handle viscous, non-conductive fluids hard to measure by other techniques. Moreover, it boasts no internal moving parts and an unobstructed flow path. It does not require straight inlet or outlet runs. In addition, the meter is approved for custody transfer applications. It does have some disadvantages, of course. Units for larger line sizes can be expensive. Some designs, particularly U-tube versions, can be bulky. In addition, the meters come in only certain line sizes and in a limited selection of materials of construction.
Thank you for watching. For more information on flow meters and other instrumentation, check out chemicalprocessing.com/category/instrumentation. A.W. Lake, high-quality flow measurement instrumentation. A.W. Lake offers a wide selection of flow meters. Their flow sensors offer the output you need with complete system options. Learn more at aw-lake.com. KROHNE is the worldwide technological leader in the development, manufacturing, and distribution of accurate, reliable, and cost-effective measuring instruments for the process industries. Learn more at us.krohne.com.